mathematicians, let's talk about how to find the area of a trapezoid. So looking at this shape, we don't really know an area formula for it yet. So we need to figure out how we can discover it. To start, we're going to try and make this shape into a shape that we already know how to find the area for. Okay, I'm going to, you know what I'm going to do? I'm going to double it. We're seeing it now? Maybe, maybe not. Watch this. Getting closer, getting closer. Wait, that's a parallelogram. Okay, so two trapezoids together, when one of them gets flipped upside down, they make a parallelogram, and we do know how to find the area for that. But area is base times height, and this is two trapezoids, and they have different sizes. You know, like this line right here is different from this line of the trapezoid, so what do we do? Well, trapezoids have two different bases. They're called base 1 and base 2. So creative. So the bases are the two parallel lines in a trapezoid. It really does not matter which one you say is base 1 and base 2. If you wanted to call the shorter one base 2 and the longer one base 1, that's fine. So long as you're not calling them both base 1 or both base 2, you're good. So when we have them together as a parallelogram, to find the total base, you have to add them. So you notice here how base 2 is on the bottom in the left, but base 2 is the longer base, and it's right here when you turn it upside down. So you have to add the shorter base plus the longer base to get the total base of your parallelogram. So that looks like this. In parentheses, B1, which is base 1, plus B2. How do you find the height? Well, the height goes from one base to another. So remember, you need that right angle. It is not a side length like over here. It needs to form a right angle. Oftentimes it's inside, but you could also have a height line that was drawn on the outside. It would just be in a dotted line to show you that that's not actually part of the side length. So there's our height, but ultimately this shape is not a trapezoid, it's a parallelogram. So how do you find the area of just the trapezoid? Well, you get rid of the second one, and you just have that. So adding their bases together was because we had two trapezoids. So when we take it back down to just one, we're going to cut that answer in half. So half of the two bases added together times the height is the area of just that one trapezoid. In your notes, you have two versions of this formula. You have half times base 1 plus base 2 times height, or you have base 1 plus base 2 times height divided into two groups. It's whichever you're more comfortable with. I write it as 1/2, but oftentimes think of it as dividing into two groups. It's just whichever one makes you remember the steps. All right, so speaking of the steps, it's not just an area formula. You need to be careful when you are working on these problems to make sure that your work stays organized. So step 1 is always just write the area formula. Don't even worry about what the problem says. As soon as you understand what shape you're talking about, look at the trapezoid. Okay, stop reading, write your area formula for a trapezoid. Because now you have a space to go plug in the numbers you read as you're working. So I can see that one of the bases is 12 and the other base is 8. I can also see that the height is 10, so I'm going to go plug those numbers in. Still not doing any math, just writing them in the spaces that they belong. Always we do our parentheses first, so we're going to start with 8 plus 12, which is 20. I'm going to rewrite so that I never forget where I am. And then you have options. I'm going to multiply the 1/2 times 20 here. If it made you more comfortable to multiply the 20 times 10 and then cut it in half, that's fine too. So long as you're multiplying two of the three numbers together, and then in the next step you'll multiply it by that third number, it does not matter the order. So I'm going to do half of 20, which is 10, and then 10 times 10, which is 100. Don't forget your units. It's area, so you're using your units, which in this problem was centimeters, and it's squared because ultimately we did centimeters times centimeters. That's how you find the area of a trapezoid.